Hello, can you hear me?
Hi, yes, I can hear you. Good night.
Okay,
Or
good
morning.
morning from my side. Okay,
Yes, yes.
okay. So basically, you enroll our online training program on water quality monitoring. So mainly, how we can easily monitor the different types of parameter using remote sensing technique, as well as you also want to learn about the machine learning approach, how you can easily add also machine learning for the water quality monitoring. So basically, it's our total 7 days online training program. Okay, and within these 7 days I will try to complete all of details from beginners to advanced level, and I hope you can easily learn all of these things. Okay, and okay, so before that, did you use before for any Google Earth Engine platform before?
I have used it, but not in any type of project. Just this year, this semester, last semester, learning on purpose for my project in school.
Okay, okay, let's go. Okay, not worry about that. Okay, we will try from start to beginners level, and then have to go to the advanced project. Okay. Okay, so let's start. So you also get the recorded video class also. Okay, when you can easily revise your video and you can easily get the understanding about it. Okay, so let me share my screen.
Okay, perfect. Thank you.
Can you see my screen now?
Let me see. Yes, I can see.
Okay, so we start from that. Okay, so hi and welcome to the 7 days online training program on water quality monitoring using machine learning in Google Earth Engine platform. So basically, in this online training program, you will learn from all of things from beginners to advanced level, and mainly in this time we focus for that water quality monitoring project. Okay, so I will try to explain all of things for that water quality, how we can easily monitor using the remote sensing technique combined with machine learning method. Okay? So that's why you can also learn the machine learning as well as you can also learn about that water quality monitoring using remote sensing technique. Okay. So first of all, I try to discuss about our full syllabus, mainly what you will learn after completing the total 7 days online training program. Okay. So first of all, we try to discuss about that introduction to remote sensing for water quality monitoring. Mainly, what's the background for water quality monitoring using remote sensing, and how we can easily access the water quality information from the remote sensing. So this is our introductory part, how we can easily work with that. Then we talk about that monitoring the turbidity. So basically, turbidity is one kind of more important parameter for the water quality. It depends on the turbidity, and how we can easily extract the turbidity using remote sensing technique. We also talk about that, and also make the temporal change. How we can easily make the temporal change, mainly time series chart for the different time. What is the condition about the turbidity? We also talk about that, as well as we talk about that chlorophyll. Chlorophyll is another important parameter for that water quality parameter. And we also talk about the temporal analysis about the chlorophyll, when it will be high, when it will be low. We can easily get this idea from here. And we talk about that total suspended solid, well, TSS. It's very important parameter. We also talk about that, and also make the temporal analysis about that. And we talk about the salinity. It's very important for that salinity index, how we can easily monitor the salinity of water body, and then how we can easily make the temporal change or different things we can easily do for the salinity. And we talk about the BOD, mainly biochemical oxygen demand of water body, how we can easily monitor. And also talk about that COD, mainly chemical oxygen demand, and talk about the pH of water, and all of things we will do using the remote sensing technique, not any kind of laboratory test. Okay, laboratory test is also important for checking the accuracy. Suppose you want to check the validation. Suppose you want to collect the data from remote sensing technique using the TSS, and now you want to check your validity about your data. So for that, we also need to check some machine learning algorithm, and then further we try to check our model performance or model evaluation. So these type of things, when you want to do, you need the ground truth data. So I also show you that how we can easily work with the check the accuracy. So that's why you can easily use this knowledge for your own study area, on for your own water bodies. You can easily check the evaluation about that all of parameters: TSS, salinity, BOD, COD, PS. Okay, as well, I talk about that time series chart for all of parameter, how you can really create together. Suppose I want to check at the same time turbidity, chlorophyll, TSS, salinity, BOD, COD, PS, all of parameter, and to make the time series chart at the same time and check my result analysis. Okay, combine all of parameters: total suspended solid, salinity, BOD, COD, PS of water. So all of parameter I consider, and then I take the final decision. It's a uh, polluted water or it's a normal water. Okay, I can decision
Okay.
according to my all of parameter I consider. And in this time, we will not only talk about the parameter, as well as we also talk about that web application. Suppose how you can easily build a web application. So using this web application, how you can easily monitor the water quality monitoring. Suppose I can easily make a web application, and from this web application, I can easily monitor the water body. Anyone can, any user, they, when they simply go to this website, they can easily check about their water quality parameters. They can easily check what's the status of their water body, where the high density of chlorophyll, where the high density of the total suspended solid or salinity or BOD or COD, all of parameter they can easily monitor using this web application. So I also show you that how we can easily create this type of web application from beginners to advanced level. So I hope you can easily do it, and I will provide you all of practice code. It also beneficial also for you. You can easily learn all of those things. When I provide you the practice code, you also try to practice using my code. I hope you can easily get the solution. Not only for that, when you face any problem regarding any issue in your code, or you don't understand what in this code, you can get the lifetime teaching support. So basically, when anyone join my online training program, they can get the lifetime teaching support regarding this online training program. So you also get the lifetime teaching support when you face any problem regarding any issue in remote sensing or water quality monitoring. You can simply text me in WhatsApp. You can easily get the feedback for lifetime. Okay.
Okay, thank
As
you.
well as we'll talk about that how we can easily use the in situ data. Mainly, it's our ground truth data. Suppose you can simply visit your study area. Suppose you can simply visit your lake or water bodies, and further you can take some training sample. Okay, so it's called the in situ data. Suppose you want to take the training sample of water body, and further you can simply go to the laboratory test, such as you can test for the TSS, salinity, BOD, COD, PS, all of parameter. You just simply uh, test, and further it's our data. Okay, so this data we can also use in our model to check the performance of our machine learning model, what is the accuracy, as well as also what is the evaluation we check from the in situ data. Okay, further I'll also show you that how you can work with the in situ data, because I already worked a lot of time for water quality monitoring using remote sensing. So that's why I have a lot of data about the in situ data. I will collect all, for the different sources, and I will just use it and try to show you that how we can really work with that in situ data to make the accuracy for all of parameter: chlorophyll, total suspended solid, BOD, COD, PS. Okay, and
Okay.
further we talk about that LG bloom. So it's very another very important water parameters, LG bloom. Okay, so some bloom is very harmful for human life, so that's why it's very important, and we can easily detect the LG bloom from using the remote sensing technique. As well as we will talk about that correlation analysis. In this time, it's very important for the correlation analysis, because this type of, suppose total suspended solid, salinity, BOD, COD, PS, so all of parameter have some correlation with precipitation, with temperature, with wind speed. Okay, so this type of things I also try to show you that. Suppose correlation, you want to check what the correlation with LG bloom and wind speed. We can easily get that positive correlation, because the flow of wind, it also make the high concentration of that algae bloom. Okay, suppose where flow
Okay.
is high, where wind flow is high or wind speed is high, we find out this place is also high about the Lg bloom, as well as temperature, precipitation. Mainly this type of climatic factor or temperature or precipitation, wind speed, this type of factor, how the correlation with total suspended solid, BOD, COD, PS, LG bloom, we have to check it, okay, using the different types of linear regression model. Okay, so it's another very important topic for that, because it must correlate with our weather data, okay, or climatic data, wind speed, temperature, precipitation, humidity. So this type of things we correlate with our water quality parameters. So these things I
Okay.
also try to explain one by one. You can easily get this idea. And we also talk about that water quality evaluation is Google Earth Engine platform. Okay, and we talk about that machine learning. Okay, how we can easily work with the different types of model such as random forest or classification trees or different types of artificial neural network. So this type of things, how we can easily implement in water quality using the different types of algorithm. Okay, so this is a full syllabus. Okay, we explain all of those things all of, properly and complete all of this topic. Okay, and each day I will provide you that 3 hours, 1 hours meal, 2 hours meal our live training, and 1 hours for your problem solving. Okay, suppose I also
Okay.
every class I also give you some assignment regarding this topic. So you can just simply do this type of algorithm assignment, and further you face any problem, then we talk about the 1 hours problem solving class, or with your any problem we also talk about that in 1 hour class. And 2 hours I will provide you the live training session. Okay, so now let's
Okay.
go our class for today's class. So first of all, I talk about that how we can easily, mainly in this time we are using the remote sensing technique. And remote sensing technique, basically we need to use the different types of sensor or satellite imagery. Okay, so we have to need to use the some different types of satellite imagery, and mainly for the water quality monitoring we are just use this type of satellite imagery, Landsat 8 and Landsat 9. Then we also use here the Terra and Aqua satellite imagery. Also you can see about the visible infrared imaging radiometric suite. We also use here the Sentinel 2 satellite imagery, multispectral imager, or we can also use it, as well as we also use here the Sentinel 3. Okay, mainly it's ocean and land color instrument. So I will show you all of sensor, mainly how it will be work. I will explain all of satellite imagery in Google Earth Engine platform, and also monitor the water body parameter. So basically this type of satellites we are use, and this type of sensor we are also use for that. And you can see the resolution about that. Okay, and also you can see about the their revisit day. Suppose 16-day revisit, and Terra Aqua we can get the 1 to 2 day revisit. Then we can get that 1 to 2 day revisit. For Sentinel we can get the 5 day revisit. Revisit means that when you want to make the temporal chart, we can get the every 5 days interval. Suppose I can get the first one data for that 1st January, second data I can get that 6th January. So it's a revisit. Suppose we can get the same location. Okay, so in this time you can see mainly how it will be work for that water quality in remote sensing. So basically in the water particle we find out some different types of material. Okay, suppose it can be turbidity, or it can be total suspended solid, or any kind of material. So when the water body have this type of material, then natural water contains a material that is optically active. Okay, and monitoring light reflectance. Suppose when this type of material, suppose in this, suppose it's a water body, and this water body have some particulate matter or this type of material, when the reflecting of the light on this water surface, it can indicate the quality of the water. Suppose when some sensor, suppose from the sunlight, hit on the water body and reflect it. Okay, and it is stored in our satellite imagery, and from here we can easily detect it's the water body or not. Here you can see it's the example about that. You can see the light penetration in open ocean. We can get the light is go to the depth. Okay, in the open ocean. Also you can see about that in the light penetration in the coastal areas, we can get only for this region, only for this 50 meter, because in this time there are the lot of particulate matter, there are the lot of total suspended solid, there are the lot of material. Okay, for this region, this light, it's one kind of sunlight. This sunlight cannot go to the more depth, but in the open ocean, when you want to check, we can get that sunlight move to the more depth, because in the open ocean we did not find out the more particulate matter or other types of materials, it we cannot find out. But in the coastal waters as well as the lake waters or any kind of inland waters or pond water, we find out this type lot of material, lot of things. So that's why the light penetration cannot move to the more depth, it will be just in here. So it's one kind of way to it also work look like that. And there's a lot of way to use the remote sensing technique, further we talk about that. And in this tab here you can see, when you want to make that your water quality, remote sensing of water quality, so basically satellite sensor measures top of atmosphere radiance. Okay, so top of atmosphere radiance, so basically it's one kind of sensor. We can easily get this sensor for Landsat imagery. We also get the sensor for that Sentinel-2 satellite imagery. Okay, top of atmosphere radiance. Okay, and the top of atmospheric radiance result from a combination of surface and atmosphere condition, including the effect of the cloud and aerosol particle. So basically it's one kind of characteristics of top of atmospheric radiance. So top of atmospheric radiance result from the combination of surface and atmospheric condition, including the effect of cloud and aerosol particles, and mainly water leaving the reflectance depths on the on backscattering and the absorption of the radiation due to the water, sediment, phytoplankton, and color dissolved organic matter. So that's why this is the main reason to use the top of atmospheric sensor. Okay, so when I will show you the practical example, all time we are using at the top of atmosphere. Okay, top of atmosphere sensor, it's one kind of sensor, and this sensor mainly it's combined of atmospheric condition, including the effect of the cloud and aerosol particle. And mainly when you want to work for the water, suppose I want to check what's the atmospheric reflectance data in a water body, it depends on the backscattering and absorption of the radiation due to the water, sediment, phytoplankton, and color dissolved organic matter. So that's why all time when I use the satellite imagery, it can be Landsat or Sentinel, all time we are using at the top of atmosphere, all time we are just use, we are not using the surface reflectance, we are just using at the top of atmosphere. Okay,
So is it a type of raw image
no,
that hasn't been
top of atmosphere is created from the raw image and it atmospherically corrected. And Google Earth Engine platform, so that's why you're using the Google Earth Engine platform. Google Earth Engine platform, it's provide you this type of top of atmospheric imagery directly without any kind of need. Suppose when you want to download the satellite image from raw image, then we face a lot of problem. We need to make the correction, we need to radiometric correction or atmospheric correction. But in this time when I use at the top of atmospheric this radiance, then we don't need to put any kind of correction because it's already corrected all of things.
okay?
Okay, so that's why it's very easy to way we can use there the Google Earth Engine platform. Suppose I will show you the one example. So I hope you already open the Google Earth Engine code editor. Did you open the Google Earth Engine account or not?
No, I'm opening it right now.
Okay, so you just simply go to the Google Earth Engine, simply search on the Google, and you can see the Google Earth Engine. Just click on here, and further you can simply click on that. You can see the non-commercial and commercial. So simply click on the non-commercial because students, scientists, they can easily use the Google Earth Engine non-commercial. So just click on here, and further you just simply click on, you can see the get start button. Okay, then further you can simply make the registration with your Google Earth Engine. Okay, just you need to fill up a form. You can see the register a non-commercial cloud project. Okay, and then simply click here, sign up the form. Okay, just you can click here, and now it provide you this type of form, and then you can simply complete the registration. It's very easy. Okay, because I already registered in this time. So in this time, you try to restart the Google Earth Engine account, and when you successfully registration, then you can simply go to this link. You can see this is the link about that code.earthengine.google.com. Just simply go to this link, then it automatically open the code editor. Okay, so this is our code editor. Basically, it's a Google Earth Engine JavaScript API code editor. In this code editor, you can write only for that JavaScript programming. Okay, it not supported the Python. For the Python, mainly we also learn about also Python because we need to learn about the machine learning. So that's why Python is also very important for the machine learning. So I also show you the later. In this time, this is our code editor. In this code editor, you can write only for the JavaScript API code editor. Okay, and in this code editor here, you can find out this type of, you can see the browse data catalog. Okay, simply click on here. So now it will be open all of sensor, all of satellite imagery. Here you can see. Suppose I want to work for the Landsat or Sentinel. Suppose I want to work for the Sentinel. Just click on the Sentinel. So now I can get all of Sentinel image collection. Here you can see Sentinel 1, Sentinel 2. Sentinel 2 is a multi-inspector instrument. Just I click on here. So now I can get all of sensor. Mainly, you can see we can get the two type of sensor. Surface reflectance. We also get about the top of atmosphere reflectance. Okay. So in this time you can see top of atmosphere reflectance is ready. Okay, so just we are just use here this image collection, and further we can easily monitor the water quality parameters. Not only for that, if you want to check for the Landsat, suppose I want to check the Landsat, just click on the Landsat, and here you can easily find out that suppose you can see different types of version, because Landsat 9, Landsat 8. You can also see about the time period. So basically it's different on the time period. You can see Landsat 9 is available from year of 2021 to present time. Landsat 8 is available 2013 to present time. Landsat 7, just simply open suppose Landsat 8. And here you can find out this also about that top of atmosphere. Okay, so in this time for water quality monitoring, all time we are using at the top of atmosphere reflectance, or TOA. It is the top of atmospheric reflectance we have to use in here. So this is our image, Landsat and Sentinel. We got the top of atmospheric image collection, and we can easily use it in Google Earth Engine platform to monitor this type of things. Okay, so now back to the slide. Yeah, so this is the characteristics of the top of atmosphere. Okay, also you can see, okay, so this type of things we also try to show you that practically. So basically for the chlorophyll concentration, how we can easily work with that for water body, we also talk about that. As well as also you can see it also show about the trend analysis. Trend, mainly what's happened for, what is the trend about that, it will be high trend or low trend for the chlorophyll concentration. This type of things we can easily get from here in Google Earth Engine platform, and we can easily monitor the trend analysis using this. In this time here you can see it's one kind of project for the chlorophyll concentration for this water body, and as well as we can also generate what's the trend about that, it's the high trend or low trend. So in this time we find out that you can see it's go to the upper, so it means that it's the high trend. So that's why increasing the chlorophyll day by day, it show about this result, increasing chlorophyll day by day. As well as also you can see about that this is our map for that chlorophyll concentration, and this work we can do in Google Earth Engine platform. As well as also you can see in this time basically we talk about that, suppose how we can easily create this type of chlorophyll concentration map. Okay, so today's session I also try to explain all of these practical things, how we can easily create, as well as how we can easily create this type of time series chart and check about that what's the trend, it is the high trend or low trend about the chlorophyll. Okay, so let's go, we try to explain one by one. So in this time we talk about the normalized difference chlorophyll index. So its short form is the NDCI. N for normalized, D for difference, C for chlorophyll, I for index. Okay, so it's one kind of very popular index. Okay, for monitoring the chlorophyll on the water body. So here you can see basically NDCI is an index that aims to predict the chlorophyll content in turbidity productive waters. Okay, suppose turbidity production water we can easily identify using the NDCI or chlorophyll index. This NDCI it's mainly used for to predict the chlorophyll content in turbid or productive waters. It's calculated. You can see what is the equation about that. It is calculated using the red spectral band with the red is spectral band, mainly band 4 and band 5, and red spectral band and red is spectral band. This red is spectral band is only available for Sentinel 2 satellite imagery. Okay, so basically NDCI when you monitor we have to use the Sentinel 2 satellite imagery, because here you can see I will show you that for the Sentinel 2 imagery we can easily find out that in this time you can see you also get the information about the band. In this time you can get the band name also about that. Okay, so coastal aerosol, blue, green, red, near infrared. In this time there is no red S band is not available. Red band is available before, but red S band is available only for the Sentinel. Suppose I simply click on the Sentinel, and we can easily find out that Sentinel 2 imagery. Just I click on here. From this satellite imagery, I can easily access that one kind of information band. It's called the red S band. Here you can see red is 1. Okay, so B5, red is 1. Okay, red is 2, red is 3. So that's why in this time when you calculate that normalized difference chlorophyll index, you must use here the Sentinel 2 satellite imagery. Okay, otherwise it not work, because Landsat is not available for that red S band. And
Great.
it's one kind of novel model for remote sensing to estimate of chlorophyll-a concentration in turbid productive waters. Suppose turbid productive waters you want to identify, then you must use here the NDCI, and this is the formula about the NDCI. NDCI formula equal to red S band, so basically it's the B5 minus red band divided by B5 plus B4, red S band plus red band. So when you just apply this formula, then you can easily create the normalized difference chlorophyll index. And you can see this is another things about that remote sensing technique for monitoring the LG. So further we talk about that how can we monitor the LG bloom. Okay, we can easily monitor about that. Also correlation. Also you can see how we can easily create this type of web application. Okay, so further class will also discuss about that how we can easily create this type of web application to monitor the different types of parameters. So it's one kind of web application. Any users they can easily select their water body and they can monitor the all of parameter, total suspended solid or chlorophyll or turbidity, and they choose their time period from here, and then you can easily get this type of visualization about that total suspended solid legend. We can get this type of animation, also you can get this type of time series chart. Okay, so this type of things we also try to discuss further our class, and then you can easily get it. Okay, so today's session we talk about that how we can easily make the NDCI, mainly normalized difference chlorophyll index, and also make the time series chart. Okay, so let's go try to start about that. So I just simply open my code editor. So this is my code editor. Okay, and in this code editor I can write my code. Okay, you can write any code in here. So in this time, okay, so do you know about the JavaScript programming or not?
I had a class. I think I can understand it a little.
Okay.
Enough.
Okay, so I will explain about that JavaScript programming, because in this time we write all of code in JavaScript language program. So it's very easy. Just you can, and we can get all of information about that data set availability. We can get that time period about that. We can get the image from year of 2015 to 2024. This time period we can easily get images, and we also get that you can see the data set provided European Union, yes, Copernicus. We can get that Earth engine snippet. Okay, so basically it's a ID. Okay, this is the ID of this image collection. You can simply copy this ID and paste on your code editor. Okay, and further just give a variable name. Okay, and before the variable name just put here the var keyword, and then put the variable name, suppose Sentinel. You can put any name as the variable. This name can be anything. So now this image collection is stored in this variable. Okay. So now further you simply choose a water body. Suppose you can simply choose your study area. Suppose I just work for that any study area. Suppose I want to choose so this is my study area. I want to choose it. And further I just simply draw the rectangle. Okay, so just I simply click on the geometry, you draw the rectangle, and then simply draw your study area. Suppose this is my water body. I want to observe from this water body. Okay. So in this time here you can see it also another variable geometry. Okay, you can put any name. Suppose I put the name is that RY. Okay. So now this is my study area. I simply select, as well as I also put my image collection. Okay. So now further in this time I need to filter this image collection. Okay. So filtering image collection, when you want to do, we have to consider some things. One factor is that where you need this image, then how, and then when. Okay. So where you need this image, how, and when you need this image. So for that I simply put here that for where I just put here the filter bounds function. Okay. For where you need this image, I need this image for this study area, and this study area mainly it's our ROI. So just put here that ROI. Okay. And how you need this image, suppose I need this image less than 1% cloud cover. Okay, I need the image less than 1% cloud cover. So for that I simply use here the filter metadata and put all of parameters such as name, operator, and values. Name mainly image properties name. You can easily get it from here, image properties. You can see, you can simply copy the, suppose I work for the cloud pixel percentage, simply copy and then just paste here. An operator, I set the operator, suppose less than 1. Okay, so in this time here you can see I just filter metadata mainly it's filtering image properties. Suppose I need only for this image which image will be not more than 1% cloud cover. Okay, just I simply call the cloud pixel percentage less than 1. And further, when you need this image, suppose I put here the filter date for that. When I need the image, suppose year of 2023 from 1st January, from year of 2023, suppose I put here that 0630. Okay, or you can put any time period. Okay, so here you can see for the filter bounds where I need this image, filter metadata, how I can filter this image, and filter date when you need this image. So filter bounds, filter metadata, and filter date. So basically these three function we use for filtering our image collection. So this is our full image collection. It stored the whole world image collection for full time period, year of 2015 to 2014, all of image collection. Okay, so that further I import this image collection and use here the filter bounds function, filter metadata function, and filter date function for filtering for my own condition. Okay, so now if you want to check how many images are available, suppose use here the print function and call the sentinel. So now it's printing how many image collection are available, which is available for year of 2023 less than 1% cloud cover, and also available for this study area. We find out how many images. You can see we can get that 56 images is available for this study area is available. So now further I just click on here you can see about all of images date. Just click on here, click on the feature, we can get all of images, single images. Here you can see this is the first image.
Okay.
All of images we can get from here. In this time, suppose you want to work for a specific image. Suppose you want to work for this image. Suppose I want to work for this image. Okay. So what can I do? I want to visualize only for the single image. Simply copy this ID. Copy this ID, and further just take a new variable. For I variable name is the suppose image. You can put any name as a variable. Equal sign ee dot image, and then put here this ID which you paste. So now if you want to visualize it, suppose I just simply add a layer, map dot add layer. So basically this function add a layer of your image. So in this time I have to add the layer for this image. Simply copy the variable and paste here. So now click to the run. In this time you can see it added the layer about that. Okay, you can get this type of layer, you can see. But in this time it show for that your whole tiles. Okay, it show about the whole tiles, but I want to need only for this boundary, not for other area. I don't consider. So for that you just simply use a function. It's called the clip function. Clip with study area, which is ROI. Mainly it's your region of interest, which you already put in here. You can see ROI. Okay, just I clip with that. So now click to the run. In this time you can get the result only for this boundary. Okay, it look like that, totally black color. Okay, so now I want to add the set the visualization. Okay, so how I can set the visualization? Just simply click on the, you can see the setting button. Just click on here, on this button, and then click on here. Suppose before it's a red band,
Okay.
green band, and blue band. Okay, RGB color, mainly it's true color composite or natural color. Just stressing 98% for better looking, and further just apply. So now you can see it added this satellite imagery. Okay, we can get our satellite imagery look like that. So in this time, this satellite imagery we can get, this is our water body, and we can also get this type of other feature. So you can see here I just apply the visualization, red, green and blue. It's called the RGB. When I put the red, green, blue, then I can get this type of visualization. Suppose I put at another band combination such as near infrared, then for near infrared it will be B8. B8 is the near infrared for Sentinel 2 satellite imagery. Then put at the red and blue, custom stressing 98%. 8%.
Does that just make it bigger?
It's mainly stressing is one kind of visualization process. Suppose data visualization, when I stressing it look more better. Okay, so 98% is random layer use, and we can also
It doesn't change the information.
yeah. So now apply it. So in this way we can get that this type of, you can see water body look like black color or dark color we can get. So it's another band combination. It's called that false color composite. False color band combination means that first of all near infrared band, then red band and blue band. Not only for that, you can simply search on the Google. Suppose band combination. Suppose band combination of Landsat 8. I simply search here, and from here you can easily get that lot of information about the band combination. And we are using the different types of band combination, and we can easily detect the different types of things, different types of feature from the satellite imagery. So you can, yeah, so here you can see the natural color, mainly red, green and blue. Then I can get the natural color. And when you put here that, you can see near infrared, then red, then green, we can get the this type of color. Okay, also you can see about that short of infrared. So there are a lot of band combination are available to detect the different types of feature or object from the satellite imagery. Okay, so I'll also send you this link after completing the class. You can easily read it. You can get a lot of information about that. Okay, so in this time we concerned about that water body. We're not concerned about the other types of feature. Okay, because we just work for that monitoring the water quality. Okay, and we can easily get this type. It's a water body, you can easily get it. Okay, but in remote sensing we are also use some index to detect the water body from satellite imagery. Suppose you can simply search here water index in remote sensing. We can get the lot of water index for remote sensing to detect the water. Okay, that we can easily get that water body. Suppose I simply open some images. Suppose here you can see okay, just I try to open from here. So here you can see it provides some water body formula, and it provides the different types of scientists. They are already mentioned their citation. You can see about that, and it will be developed in the 1985, 96, 2004, 2005, 2007. So different types of scientists already developed the different types of water extraction index. So basically when I apply this type of formula, then we can easily get the water body from satellite imagery. Suppose you can see NDWI. Okay, so it's normalized difference water index. So NDWI, what is the formula about that? You can see near infrared minus short wave infrared divided by near infrared plus short wave infrared, and it provided this. Also you can see NDWI, it also green minus near infrared divided by green plus near infrared. It also provided MC filters in 1986. Also you can see NDWI also provided that red band minus short infrared. So it's different types of equation to identify for this water body. Okay, suppose in this time I want to monitor the water quality for this water body area. So this is my water body. So in this time I want to extract the water body from this satellite imagery. Okay, so for extracting the water body, we are just need to use this type of formula. You can use any one, no problem. Okay, suppose I want to use this second formula or first formula or third formula, also MNWI. So you can use any formula to detect the water body from satellite imagery. Okay? So suppose I want to use the second formula and then detect the water body from this satellite imagery. Okay, so let's go, we try to do that. For doing these things, okay, as well as also you can see import option. Okay, so this visualization I want to import on my keyboard editor. So just simply click on the import and then copy and then paste here. Okay, I put it the layer name. In this time you can see it show the layer 1. It show that layer 1. I put this layer name as a imagery. Okay, you can put any name. In this time click to the run. In this time you can see it show about that imagery layer name which I put in here, as well as also show about the satellite imagery. So now I want to extract the water body from this satellite imagery.
Where did the image Vistaram come from?
It's come from, you can see, I just simply click on the import button, then a new variable also added in here. Okay, in here simply
okay.
copy and then further I paste after the our layer name, after our object name. Okay, just image, just put in here, then put here the layer name, then it also added the layer. Okay. So now we talk about that how we can easily extracting the water body, okay, from this satellite images. In this time we put the formula NDWI formula. Suppose I want to use this formula green minus near infrared divided by green plus near infrared. So just I put the formula in here. So I write the formula. Suppose its formula is that green minus near infrared divided by green plus near infrared. Okay, so now I just try to apply this formula and then extract the water body from here. So let's go how I can do that. Very easy, just take a variable, suppose NDWI equal, I call my image, so this is my image, okay, and paste here because I want to use this image and extract the water body. And then I just put a expression, Okay, expression function. When you want to calculate this type of equation, you have to use here the expression. And I put the expression equation is that, suppose green minus near infrared divided by green plus near infrared. Okay, so this is my expression. And now further I put the curly bracket. In this curly bracket I just put here what is the green, what is the near. So I put the keyword green and then put the key value of the green. Green mainly come from this image. For selecting a specific band, this band name is that B3. Okay, because you can see here B3 is that green band. You can simply click on the bands. Here you can see the B3 is the green band. Okay, just I put here the B3 band name. And further, what is the near infrared band? So just I put here the near. Near is also come from this image for selecting the specific band which is B8, because near infrared is the B8, and put here the comma sign. Okay, so now we can calculate the equation. You can see using the expression. Just keep a equation look like that, curly bracket. In this curly bracket I just simply put here the green. Green is mainly come from the image, and select the B3, and near infrared band it also come from this image, and select the B8. Mainly image it stored all of band. Here you can see when you print that image, suppose just I simply print this image, it show the all of band. You can see it printing. I just simply click on the bands. It's available all of band B1, B2, B3, B6, all of band is available in here. So just I simply call this image and select only for the single band B3, which band I want to need. I need the green band, so just I put here the B3. I need the near infrared band, so I put here the B8. So now display the result. Suppose I want to visualize this NDWI, so just put here map.add layer and call the NDWI. Click to run. So you can see it also added the another layer, and it look like that. So just I click on here, and then I further, you can see it show the B3. Okay, so it show the default B3. When I put the rename function, suppose I put here the rename as a suppose NDWI. So now it show the NDWI name after rename it. Suppose click on here, you can see the it show the NDWI. Okay, I just stressing 98%, and further I just simply click on the plated. And in this time you can see another thing is that it show this type of value 15,000, 1,527. In this time we also need to rescaling. Okay, for doing the rescaling you can see here all of band is also have the scale value. You can see scale value, scale value, scale value, and scale value is the same. This scale value I simply copy and multiply. So just put here that multiply, and also for that multiply. Otherwise we did not get the proper pixel. For proper pixeling we are simply multiply with this value. It's our scale value. For Sentinel all of band is the same scale value. So just click on here again.
So every time I want an image, I have to multiply by the scale value, no matter the satellite.
No, Landsat is not needed. It's only available for the Sentinel imagery. When you want to work for the Landsat imagery, for the Landsat imagery, it also it's not needed for that. You can see here. Suppose click on the you can see in the scale is available only for that, but for Sentinel imagery. But when I click on the Landsat, okay, suppose Landsat 8, and I want to work for the top of atmosphere. Click on here. In this time you can see there is no scale. Okay? There is no scale about that. So that's why in this time when you use the Landsat imagery, then we don't need any kind of scale. Scale is mainly need for that Sentinel-2 satellite imagery. Sentinel-2. I'm stressing it.
Okay, got it.
Okay, so you can see in this we can get the floating number. Okay, I think we have to use here that bracket. Okay, suppose bracket, it also more better. Bracket. Let's put here the bracket. So now try to check the run again. So now you can get the proper result. Okay, so you try to put the parenthesis. Suppose green minus near, it's one part, and green plus near, it's another part. Okay, after that we are just division. This part and this part we are just divided. So put here the divided sign. So now you can get this type of things. And further, just click on here. Just I put here the stressing 98%. And further into add the color. Suppose I just put here that just suppose in this time you can see for NDWI positive value indicating the water body, and a negative value indicating there is no water body. Negative value indicating there is no water body. Suppose I put this type of color. Suppose for that there is no water, and negative this value I enter for the water. Okay, suppose let's try to apply.
Okay.
Okay, so now you can get this type of things you can see. Okay. Okay, so in this time it show about this is our water body. If you want to check it, suppose just in a spare time and click on here, you can get the positive value. You can see for the NAWI, you find out that positive value 0.4. Okay. For other regions, suppose I click on here, in this time we can get the negative value. You can see the negative value. Okay, negative value means that there is no water body, and positive it means that water is available. You can get the positive. Okay, so this is our NDWI map, mainly normalized difference water index. So now further I just simply import. You can see when I click on the import, just click on the import, it will be imported. Just simply copy this variable name and paste after the object name, and I put the layer name, suppose NDWI. So now it will be set up with the visualization. Okay, so now I just separate the only water body, other feature I don't need. Okay, suppose I just separate only for the water, other feature I don't need. For these things I just applying the thresholding technique. So in this time I just take a variable, suppose water body equal, and further I call the NDWI and put here greater than equal 0. Okay, why I put the 0 in here? Because I want to consider only for the water pixel, and water pixel for positive. Okay, so I just consider all of pixel from NDWI which is greater than equal 0. Okay, greater than equal 0 means that it will be start from the positive value. Okay, greater than equal 0, it consider all of positive value, and every positive value indicating the water body. Okay, and negative value indicating the other feature. It can be vegetation or barrel and other features. So just I put here the greater than equal 0, and then I just use a function self max. Okay, so it maxing self, and now I want to add the map.add layer about this water body, and further I just use here the plated. I want to put the water body color. I put the color, suppose blue color. Is that square bracket? And put the layer name, suppose water. So now let's check what happened. Okay, we have to use at the quotation. Now click the run. Okay. So now here you can see we can get this type of only one layer of water. Okay, you can see it show only for the water body for this area. Okay, so this is the process how we can use the satellite imagery and extract the water body. Okay, in this time you can see first of all this is my imagery. Okay, this is my satellite imagery, Sentinel-2 satellite imagery. From here I apply the NDWI formula, green minus near divided by green plus near. This formula I apply. After that I just simply extract the water body. So now you can see it show about the water body, only water body area we can extracting from here. Okay, so this is the process to extracting the water body. When you want to apply anytime, suppose you want to apply for any parameter, it can be total suspended solid or TSS or turbidity or pH. First of all you need to extract the water body from satellite imagery. Okay, this is our first step to monitor the water body. And when you want to apply the Landsat imagery, the same process. Okay, further I'll show you that how you can go to the Landsat imagery. So in this time you can see also some other equation, such as you can see the MNDWI, green minus short infrared divided by green plus short infrared. Also you can see NDPI, also you can see AWEI. Okay, so this type of equation you also try to study for other water body extraction equation, and then further you also try to implement. Suppose I simply search here automatic water extraction index formula. So here you can see this is that another water extraction formula. It's called that automatic water extraction index, AWE. So this formula provided this Mustafa 2017. So suppose this formula you want to use and then extract the water body. So you also try, I also give you an assignment about that. Suppose you would just try to do it, and further face any problem I also show you that, no problem. Okay, suppose you try to use this formula. This formula is that green 4 multiply with green minus short wave infrared 2 band minus 0.25 near infrared plus 2.75 multiply with short wave infrared 1 band. Okay, so this is our formula about that. Okay, so this is our formula. Okay, you try to calculate this formula and we can easily get the automatic water extraction index. Okay, so it's another formula to extract the water body. As well as also you can see, suppose I simply search here MNDWI. So here you can see MNDWI is that another formula. It provides another scientist to extracting the water body from satellite imagery. So green management. So you also try to also this about that. Okay, so you also try to do that these two things and try to work with that. So in this time I want to monitor the chlorophyll. Okay, suppose, and we already know about the chlorophyll equation. You can see we already discussed in here for the chlorophyll index. So this is my formula about the NDCI. Okay, and I want to apply the NDCI on my water body. Okay, so let's go try to apply the NDCI on the water body. Okay, so in this time just you take a variable, suppose NDCI, and then just call this image. Okay, call this image and use here the expression. And NDCI formula, mainly this NDCI formula is that I simply write here NDCI formula equal band 5 minus band 4. Band 5 mainly read as band 5 minus band 4 divided by band 5 plus band 4. So in this time I simply put this equation look like that. I put the expression is that band 5 minus band 4 divided by band 5 plus band 4, and comma and put the curly bracket. In this curly bracket I put here what is the band 5, what is the band 4. So just put here band 5, it come from this image, and select the specific band of, you can see the what is the red S band in here. So simply check it here, you can see the red S band. Okay, that's basically gonna send it again. Multi-split instrument, proper troposphere. And here you can see about that red is 1. Okay, it is the band 5. Okay, simply put here the band 5, band 5, and then further put here the what is the band 4, just put here the B4. It also come from this image, and select the specific band of band 4, red band. Okay, so now in this time when I apply it, suppose I put here the map.add layer NDCI. In this time it show the result for whole image, not only for the water body. You can see it loaded. You can see we got this result, but this result show for the whole imagery. Suppose I stressing 98%, I apply. Suppose I try to apply for that low, show this type of color. Suppose then greater than I need to show this type of green color. More greater than I need to show suppose this type of yellow color. And high concentration I show this type of red color. And apply. In this time you can see this is not only show for the water body, it also show for the other feature. Okay, so in this time I need the NDCI mainly only for the water body, not for the other feature. Okay, I need only this result only for this water body. This water body I want to need. For doing these things in this time, if you want, you can simply make a boundary shape file. Suppose you just make a water body boundary shape file. Water body boundary shape file. So how I can create the water body boundary shape file? So for doing these things, water body boundary shape file. Just take a variable. I put the variable name, suppose area water. You can put any name as a variable. Then call this water body and paste here. And use the function reduce to vector. Reduce to okay, let me check from here what is the spelling about that. Reduce to vector. Reduce to vectors. Okay, so this is our function. I simply copy.
Okay.
And then paste it. And further just make a dictionary. So curly bracket start and also curly bracket in here. And how I can get the all of argument at the same time? The shortcut keyword is that control plus space. Okay, you just simply press control and space, then we can get all of argument at the same time. So for the reducer, I just put here the reducer is that EE dot reducer dot every count Let me check on it. EE dot. Okay, count every. Sorry. EE user dot count every. Geometry, mainly it's your boundary shape file, which is RY. Scale is the resolution. I think someone should just, yeah. So now apply. Okay. So now we can get this type of result. So here you can see we find out this type of chlorophyll. Here you can see red criteria high concentration about the chlorophyll, as well as also you can see other water is show this the blue, if not mass chlorophyll. So we can get that site. Suppose you can see the river bank about that. It show the high concentration. This type of is the high concentration about that chlorophyll index about that things. Suppose you want to check the value, click on the inspector tab and then click on here. Suppose I click on here, here you can see it show about that positive value. We can get the 0.1. Okay, but when I click on this type of things, it show the negative value. It means that there is no chlorophyll. We can get this type of things. Positive value indicating the chlorophyll and negative value indicating that there is no chlorophyll. Yes, suppose I click on here, this type of things about show the high concentration about the chlorophyll. You can get the positive value. And it show the B5, but it's a chlorophyll value because we need to also put here the rename it. Suppose I just put here that dot rename it as a suppose NDCI. So now further click to run. Okay. And you can see this one imagery. So I want to add the color again. You can see it show the NDCI, okay, because I rename it. Otherwise it show the default name. So now I just try to add here this type of thing. Suppose I want to show, suppose low, I want to show this type of color. Then I want to show this type of color. For the high, I want to show this type of yellow color. And for the more high, I want to show this type of red color. And apply. Okay. So now I can get this type of map. And if you want, you can simply just import that. Just simply click the import. And then further simply copy.
Okay.
And paste after that object name. Then the visualization will be set with my code. I put it's a chlorophyll. So now I can get this type of visualization about the chlorophyll-a. As you can see, this is all of layer about that. So first of all, we take the imagery. From the imagery, we try to make the NAWI, and from that we just extracting the water body, and from that we are just make the chlorophyll-a concentration for our only for the water body area. Okay? Only for the water body area. So now I can get this type of result. Here you can see. Okay, we can get this type of result. So now suppose in this time I want to use the code for my other region. So what will layer name? So now I can get this type of map. So now I want to make the time series chart about that. How we can easily get the time series chart. For the time series chart, you are just use a function, this function called ui dot chart dot image dot series, and put all of argument one by one. So just I make a curly bracket start and also curly bracket int. The image collection, in this time I just need to create the image collection of NDCI. So for the image collection in this time, I just need to create without median. So just I simply copy, because when I put the median function, it's not a image collection, it's just a single median image. So just I create the image collection in here. I put this name Sentinel collection. So just put here the COL collection, and further I just connect this collection with my NDCI parent. Just I simply copy. I put this, it's a chlorophyll collection. Okay, so I take the another variable chlorophyll collection, and then I simply call my image collection. So this is my image collection. Created the map of NDWI. Okay, so now we can get it, and now I also want to add that chart of NDWI. So now it show about that. I want to put here that max result. So now I can get this type of time series chart, where one is show about the NWI, mainly water body, and it also show about that your show the result for that NDCI. Okay, so you can get that NDCI. You can see water body is that this time 0.9. We also get about that NDCI is the 0.61. Okay, so in this time from here you can easily download the CSV file about that.
Okay.
So just try to open the CSV file. In this CSV file, we can easily get the two results. One is the NWI, another is the chlorophyll. Okay, you can see we can get that NDCI value. Mainly, it's our chlorophyll value, as well as we also get about the water value. Okay, and further from here, you can easily calculate about the correlation between the water body and NDCI. You can easily get that correlation from here. If further we talk about that. Okay, so okay. So you can get these type of things, and if you want to check about the trend support, what is the trend about that NDCI. So in this time we try to add here this trend. So further just use here the set options, and I want to add the chart title, legend, this type of things. For the title, I put here the title, suppose it's a NDCI time series chart, and put at the v axis, mainly vertical axis. I put the title about that. It just show about that NDCI value, and further put at that horizontal axis. The title, it's a time for the different time. Okay. So further I want to check about that what is the trend between this data. It show the high trend or low trend. We can easily get it from here. To make the trend line chart,
What does the reducer function do, or the reducer expression?
reducer is an statistical function. Basically, when you calculate anything, suppose mean, average, median, mode, standard deviation, minimum, maximum, then we have to use here this function reducer. Okay, reducer. Then we define about our statistical part. Suppose sometime you need the monitoring the maximum concentration, then we use here the max. Sometime you need suppose average concentration you want to check, then put at the mean, or minimum, then put at the mean.
Okay,
Then we can
I always have to use the reducer.
Yeah, you can see the mean, or you can see the mean as well as STD, DEV, standard deviation. So this type of parameter when you calculate, then we can easily calculate these things, and then we can easily get this result from here.
Okay.
Okay, in this time we talk about the trend line, how we can easily add the trend line in here. So for the trend line, we just try to add here this linear trend lines, and linear trend line is the straight line that most closely approximate the data in the chart. And in this time we try to add the trend line using the trend line function. That's why we can easily get about that what is the condition about our data. It will be high trend or low trend. Okay, for adding the trend line, we are just simply use the argument, this argument called that trend lines, and then put here these things. And in this time you can get the two. One is that you can see NDCI is the 0 and it's 1. Okay, so NDCI is the 0, so I put here the 0. I need the tail line for the 0, just put here the 0. But when you need the tail line for the NWI, then we can put here the 1. Okay, for 0 then 1. So just I put the 0. I want to check about the trend line for that 0. 0 mainly it's our NDCI, and for that I have to put here the blank. I don't put anything. So now try to check about this result. In this way you can see it also show about that trend line. You can see it show about the trend line about this type of things. For that you can get the low trend about that between this time, as well as if you want you can also add here the more style about this trend line. Suppose in this time I just put here the some more argument. I put here the suppose type. I put the type suppose exponential, and put here that visible in legend. I just put here the true. So now try to check. Okay, I put here the exponential EX. Okay, so now I can get the result for this. You can see it also show about that our value for that exponential value you can also get from here. Okay, if you want you can also put here the trend line color. Suppose I put the another color. Suppose just I put the another argument, it's called the color. Suppose I put here the green color for better visualization. So now here you can see it create the green color trend line about that we can get from here. As well as if you want you can also make the chart for type. It's called the exponential. If you want you can also put here the polynomial. So suppose polynomial, and I put here the degree. Decrease about 3. So now we can check, we can get that polynomial type trade line in here. Okay. Suppose I put at the more increase, suppose put at that 10 and now try to check. So now you can get, you can see it show this type of carb. You can get this type of chart, polynomial, it's a carb. Okay. As well as you can also might here suppose about that line width, or also opacity. You can also put, suppose this line you want to increase more, suppose for that you can simply put here the another argument, it's called that line width. I put in here line width, W is uppercase. Suppose I put the line width is that 10. So now it also more, you can also increase the line width. You can see we can get this type of line width. And now I want to increase the opacity. Suppose I just put here that opacity, suppose 0.2. So now we can get this type of line. You can see trade line we can get, as well as also decrease the opacity about that. So that's it's look more beautiful. You can see it's the title about that. Suppose you need only for that NDCI, just you can simply remove the NWI. It's not need. Now it show about only for the NDCI, and also show about the NDCI trend.
Okay.
If you want, you can also put some dot in line in here. Suppose for that you can simply put at that another argument. It's called that point size. So suppose point size, put it as 20. Now it also creates some point on our, you can see it create this type of point, so it look more beautiful. Suppose I check our opacity, just put here the opacity, suppose 0.1. So now we can get, you can see, so click on here, you can see it create this type of point.
Okay.
Further, if you want, you can simply download the CSV file format, as well as also download the PNG file format. It also show about the trend. You can see, you can get the load trend about that. Basically we are using at the exponential type. Okay, suppose put at that exponential, and for this degree is not need, polynomial for the degree is needed. You can see in this time we can get the totally straight line. Okay, but when you want to put the polynomial, then we can get the some curve about that. Okay, you can see this is the trend about that we can easily get. Okay, for this time series chart we can easily get the trend. What is the trend about that?
Yes. Okay.
Okay, so basically this is the process about that for the trend, and also export this part. So I will send you that all of a recorded class. Okay, you can send me your email. I will give you the privately access through my YouTube channel. Okay, just you simply log in with this email in your YouTube, then you can easily get the access to watch the recorded video class. Okay, you can also send me your email in my WhatsApp, and I also send you a invitation in our Google Classroom. Okay, so I will send you the invitation in Google Classroom, all of material, all of PD slide for today's session, all of things you can easily access from our Google Classroom. Okay, so I will send you the Google invitation link, then you can easily get it, also practice about that. Okay.
Okay, yeah, sounds perfect.
Okay, so I'll send you all of this thing. Also try to practice, and also in Google Classroom I also put some assignment for regarding for today's session. You also try to do that. In it also more proficient, you can easily learn all of those things. And further, when you face the problem, you can just knock me. You can get the supported about that. Okay. So okay, you can also try to practice, and next day we also meet for the same time. Okay, and then continue our class. Okay, thank you for joining. Okay.
Yeah. Sounds great. All right. Thank you.
Okay, thank you. Okay, have a good day. Okay, bye. Yeah.
Thank you. Bye bye.